Hey YouTube. Hey, I've been working on the control board for my CNC machine. I thought you guys might want to take a look. Uh, I originally had planned on building it into a computer case, and then as the parts started showing up, I realized I don't have enough room. So I've taken a piece of plasticized board and I've mounted the parts to it. It's 1/2 inch thick. And the idea would be to lay everything out so that it's open and wide, and also so that you can see how the control mechanism works. And so let's take a quick look. Let me switch the camera. All right, so the controller for my machine is this old 780 Dell that I have. I've set it up in the garage, which is weird when I open the door and my neighbors can see a computer on a desk here in the garage. Keyboard and mouse, and all the accompaniments. I've got sound. Hey look, Cambria drew on my... All right, anyway. The reason I have this here and not a laptop is because I need a parallel port. The reason I need a parallel port is because one of the first items, the computer connects to this system using a breakout board, a bob, and this bob has a parallel port. And the reason it has the reason I'm using a parallel port is because of the connectors. There's a lot of it's a DB25 connector. That's what a parallel port is called in techno speak. And the 25 represents the pins. 12 of them are outputs, 5 of them are inputs, and 8 of them are ground connections. So it's a perfect tool for printing, sure, but it's also a really great tool for this type of operation. So this breakout board has a row along the top. This area here along the top are pins that you can control in software. The software I'm using is called Mach 3, and it controls this board. You set up what each pin does. And I've, let's zoom out a little bit here. The breakout board is powered by 5 volts. The breakout board is powered by 5 volts. This is my 5-volt power supply right here. Right there. 5-volt power supply, and I've attached it to these power buses. I bought them cheap on Amazon. Basically, how they work is anywhere you've put this metal, all the screws are connected across for each section. So as an example, the power from the power supply comes in right here, and it goes to this pin. But because of this metal rod right here that's plugged into all of them, this 8-pack is all positive, and correspondingly this 8-pack on this side is all negative. So it makes it easy for me to identify what's what. Let's give a better shot. Okay, so 5 volts. That becomes important because I'm also powering these drivers. And the way the drivers work is they are a relay board. They take in 5-volt controls and they put out 48-volt power. So I've got that further up the line. And the way these work, 110 volts in and what is it, 60 volts out. So 60 volts DC comes out of the setup. I did the same kind of thing. These little buses are rated for 600 volts and 300 amps or something like that. So they can handle 110 volts AC or DC, whatever I want to do. So I bought a bunch of them, and in these ones, in this case, 110 volts AC hot. That's this block right here of 8. and this block is AC neutral. And then I've got ground, a bus bar just for ground in the middle, because ground is everywhere. I use the ground for sometimes one or two or three times per unit. So as an example, one of these is a ground wire and one of these is a ground wire. So I have plenty of needs for ground. So that's my layout. That's the board. The breakout board controls. Oh, I haven't yet hooked up my 12-volt power supply. I know I need it, but I haven't come across the need just yet. So I haven't done anything with it. Everything here is being held down. The ones on the side here, I bought these angle brackets, and I'm using those to bracket them down. It's sort of like a 5.5-inch bay on a computer. Same kind of screws and everything. So all you have to do is get an angle bracket to hold it down. And then I've just been using hollow door drywall anchors. And here's those. And basically all I do, these were a Home Depot special. The 40-pound ones are really great because they fit. I mean, they're perfect for what I'm doing. I basically drill a 9/32 inch hole with my drill. And once I've drilled that hole, then these anchors just screw in with a Phillips screwdriver. So you can just, let me grab one here. You can just screw this into the slot. And once it's fully screwed in, you just make it so it's completely flush with the board. And then after that, it comes with a regular screw, and so like this, which looks a little long, but the bottom half of these drywall anchors bust out as soon as you hit them. So you basically you bust out the bottom of this drywall anchor, and then for me, I'm just going to grind them all off with an angle grinder on the other side. This board is 1/2 inch thick, so I should get at least that much holding power, which for me, even if this was laying on its side, it's enough. So that's the setup. These I only have one driver fully These wired. Driver boards are actually pretty simple as far as their design. The items on this side are the controls. If you were trying to tell a child how to get to a location, there's two things they need to know. One is direction, and the other is the number of steps. And that's really all this is these items right here, pulses. Every pulse represents a step, and so the breakout board knows to send so many pulses. And then there's a DIR direction, also 5 volts, and it's which way to go. Spin it counterclockwise or spin it clockwise. That's something you need to know if you're a motor. The other thing you need to know is how many steps, and the steps are 1/8 of a degree. So for each step you take, you get 1/8 of a degree, and you just need to, if you want to tell it to go an inch, well, how many degrees is that? And that's a matter of software. You program it in, you tell it to go that many steps, and measure how far it actually went. And if it's wrong by too high or too low, you adjust it. So it's the number of steps and what direction. And then on this side, this wire right here represents the wire going to my stepper motor. There are 4 connections. There are 4 connections because there are 2 coils inside the stepper motor. So when they switch north and south, it can take an incremental step one direction or the other on one of the 2 coils. So if you set one coil for north and one coil for south, it'll move a fraction of an inch to take that single step. So that's that's what these 4 wires go to. They go to the 2 coils, which are just the wires on the side of the stepper motor. These other 2 wires are the 60 volts coming from my power supplies. I have 4 power supplies because my power supplies each can only handle 1 stepper motor. So that's why I have 4 power supplies for 4 different stepper motors. So I have to work out some programming, and the next time I show a video will probably be attempting to take steps with the motor. I'm not ready to do that yet because I haven't figured out how to tell my software to pulse the motor through the breakout board. And once I do, of course, we'll be seeing some live action. So it turns out that complicated is fun. So it's fun to play with it. It's fun to figure it out. It's fun to choose the options. I spent the weekend getting everything wired up, turning it on, using a voltmeter to make sure all the wires were connected correctly and that they were putting out the voltages that I expected them to be able to put out. All that was done over time, carefully, slowly. I also broke out the power supplies into 2 different power cords because I don't have a lot of power here in the garage. I want to say there's a 15 amp circuit, and with these 4 power supplies, I'm putting out some 1400 volts, and I didn't want to have a problem. So I have 2 power cords connected to my power supplies, the 60 volt ones, and then I can just run an extension cord from outside until I can have my garage wired properly for the voltages I need. Anyway, I hope that was an interesting look at how things are going. Like I said, next time let's look at taking tiny incremental steps with our stepper motors. Until then, have fun making, and I'll see you next time.